Welcome back to Geometry, Chapter 11, Section 6, the last one in this chapter, in this book. And I think this one's easy because you learned it, if you had me, in pre-algebra and algebra 1, it's probability. And you even learned geometric probability, maybe in pre-algebra. So if you don't like how I teach this, I've taught it 2 more times in these YouTube videos, so you can go watch the one from pre-algebra. I probably do it a little slower. Watch the one from algebra 1. I'll probably do it medium speed. So guess what we're going to do? Fast. Not too fast. Alright, so what is probability? The probability of something is always the number of favorable outcomes divided by the number of all the outcomes. For example, we're going to play heads or tails. Call it in the air. And I'm going to call tails. That was always my favorite. I'm going to call tails. So my favorable outcome, there's only one favorable outcome unless it's a like crazy coin like Two-Face. Doesn't he have, isn't his coin messed up where it's not, where it's the same on both sides? I don't remember. Anyway, my son Eli would be appalled that I don't remember. Anyway, so there's only one favorable outcome on a regular coin, but there's 2 outcomes altogether, heads or tails. So the probability of me getting the right answer is 1 to 2, or you can read it, you can also write it, let me get my marker here, you can write it 1/2, you could write it 1 to 2, you could write it 50%, you could write it 0.5. Those are all acceptable ways to write a probability. Now, where people get confused is with odds. We tend to say odds more often than probability. We'll say the word probability, but actually give it in odds. With odds, it's the number of favorable divided by the number of unfavorable. So for my coin, there's 1 favorable outcome, tails, and 1 unfavorable outcome, heads. So and we'll say that 50-50. Oh, it's 50-50. But that's the odds. And so odds is written that way. They're really the same way, 2 different ways of sort of saying the same thing. All right, I have half of a chance of getting it right. Now, probability of length is the same formula. The number of favorable divided by all. The probability of area is the same thing. It's the amount favorable divided by the whole thing. I'll show you what I mean. So here's a length one. Here it's on a number line, and we have this line RS that is 10 units long, and we have this length on the number line TU, which is 2 units long. So what they want to know is, what is the probability, if you just selected at random, of selecting a point that's on TU that's also on TS, of course. All of them would be there on TU. Well, TU is 2 units, see, 1, 2, but RS is 10 units. So favorable is 2 over unfavorable, or excuse me, over, see, I just did it. I just did the odds thing. Overall is 10. So it's 1 out of 5, you could write it 1 to 5, you could write it 0.2, you could write it 20%. It's 20% likely that if I just pick at random that I'll get on TU. Now, what about a dartboard, okay? It says, what is the probability that you're going to hit it on red? And I think this one's funny, because if it's me, I might not even hit the wall. You know, skill has something to do with darts too, doesn't it? But we're going to pretend like it doesn't, and it's just probability, all right? So here's the whole thing, and it's 16 by 16. The bullseye has a radius of 2, and the not bullseye, this white part, has a radius of 4. And they want to know what's the probability of it landing on the red. So the red is the favorable, and so we put the area of the favorable, pi r squared, pi 2 squared, 4 pi divided by the area of the whole thing. And the area of this whole square is length times width, which is 16 squared, which is 256, and I reduced that to 1 over 64. Or you can, and nobody knows what that is because it's got pi and we have no idea what that means in real life. So you fill in pi and you find out that it's 0.05, or it's a 5% chance of hitting the bullseye. I'm never going to hit that bullseye. My son Joshua, he'd hit it all day. Not me. Not that coordinated. All right. So here's another one. This one's a linear one again. You're in San Francisco and you're going to take the trolley. I've never done that, but I did take the one in New Orleans and it was very fun. So you're good. And Smyrna used to have a trolley. I ran cross country in high school and we would run along what used to be the old trolley track thing next to Atlanta Road. So little Smyrna history there for you. And that's in Georgia for anybody watching from somewhere else. All right. So our trolley train runs every 10 minutes. And it takes 8 minutes to get where you're supposed to meet your friend to at 3 o'clock. It's 2:48. What are the chances you're going to get there on time? So it's 2:48. You have 4 minutes to catch it because it takes 8 minutes to get there. So that's 4 out of 10 because the favorable is 4. 10 is the amount it takes. So that's all. And so we reduce that, and so you have a 40% chance of making it on time. Now my cousin Terry says if you aren't 15 minutes early, you're late. He thinks being late's the rudest thing ever, and he said if you're not 15 minutes early, you're late. Always plan on being, and he's a preacher, and so he gets really mad at people coming in late to his church. He wants them there 15 minutes early, sitting in their pews, talking to the people around them, getting out their Bibles, and not coming into church late. So anyway, so there's they're twins, Jerry and Terry. Terry's the preacher who says if you're not 15 minutes early, you're late. So according to Terry, she was late before she even started the math problem. All right, come back next time and we'll do chapter 12, the last one. Woohoo! Math is great.